the tightest one-shot error bound, all the basic results, like the basic properties of the random coding, and the key observation is really how to binary hypothesis testing. In the paper, so for the need many large amounts of pre-shear right in the entanglement-assisted scenario. So messages. So we need to prepare Alice and Bob. So the idea of the non-commutative really large, then we need many. This is called position-based. And in the paper, to get a tighter one-shot angle state. And in their paper, in entanglement recycling used in the asymptotic limit reduce the amount of entanglement. So tensor product, because it's independent from any other among each, meaning like we only need like each one of the M, then we only need like all the other rate. Maybe we can reduce. So let's paper. So I believe can be improved. Interesting to know if this open problem. Please to discuss with you.
Right. Thanks very much to Hao Chung. Do we have any questions from the audience? Maybe let me ask a simple question, let's say on behalf of the students. So is there any difference between pretty good measurements and square root measurements?
Yeah. Check the to the definition. And if we for each rho be n,
Okay.
and take any power, its quotient.
Okay. Okay.
Maybe we can take.
Okay.
But
right.
here,
Okay. Right. Do we have questions from the audience? Yes, Junior.
Thanks for a nice talk. So I have a question about entanglement-assisted communication. So we know there is like dense coding, like we can transmit 2 bits of classical information by entanglement state. So is this a special case of entanglement-assisted communication?
thanks. Belongs to the dense coding, the channel in general. Coding mentions like bit. In fact, the amount of entanglement the channel in the
Okay, thanks.
Do we have any last questions? Okay, if not, let's thank Hao Chung and Debbie for the excellent talks in this session. Okay.